Let's consider the following problem. For a circular wire of radius r and current I has n turns, find the magnetic moment and the torque if its symmetry axis makes an angle theta with the background uniform magnetic field. All right, so let's draw this picture here. We'll just imagine we have a coil here with n turns. All right, and this is the uniform background magnetic field. Well, that's the symmetry axis right there. And maybe the uniform background magnetic field moves in this direction. This is my B field. And this is my angle theta. All right. Okay. So, because of the symmetry of this problem, it doesn't really matter how I draw this thing, as long as I can basically rotate this until the B field is in the XY axis. All right. So let's basically do this problem now. Okay. So recall that the magnetic moment mu, or vector, is equal to the number of turns times the current per wire times the area subtended inside times the normal vector to that area. Okay, so this is going to be n is going to be n, whatever n is. I is going to be I, and the area, well, this is the radius r, so it's going to be pi r squared. Okay, and this is n hat. So the answer is pretty simple. It's just n I pi r squared is equal to mu. Okay, in the n hat direction. Now for the second part, let's get the torque. The torque is going to be equal to mu cross with the B field. So this is going to be basically n I pi r squared n hat cross that with the B field. Okay. Now the B field is in the XY plane. I mean, there are two ways of doing this, but the easiest way is to recognize that for angle theta, this is just simply going to be equal to n I pi r squared sine times b sine of theta. Right, that's the magnitude. Perhaps I should say is the magnitude, and the magnitude of the torque. Okay, in any case, hope that was helpful.